Here is our final video. This is going to be a review of the big ideas from 8th grade math, aka pre-algebra. So the first thing we're going to talk about is Pythagorean Theorem. There are 4 types of possible problems under the category of Pythagorean Theorem. If you are asked to find the hypotenuse of the triangle, then you're going to use a squared plus b squared, and your missing side is on the other side of the equation. You're going to know that it's this type of problem if the missing side is opposite or across from the right angle. If one of your missing sides makes up the right angle, then we say it's a missing leg. And you'll notice that in this type of problem, instead of adding, you're going to use subtraction in order to solve. The third type of problem, we can use the Pythagorean theorem to decide if a possible triangle would actually be a right triangle. We can do this by plugging the numbers into the Pythagorean theorem. The only important thing to know here is whatever the largest number is must be in the hypotenuse spot, because the hypotenuse is always the longest side of the triangle. So in this case, 16 is the largest number, so 16 goes after the equal sign. The last type of problem you might get is a 3D problem. Now, the 3-dimensional problem usually comes in 2 different possible types. It generally involves a box or a 3-dimensional figure, and you have to find the right triangles within this in order to figure out what the final answer is. So in this case, I've shown you one of the common problems, which is the longest distance in the box. This is the diagonal from the lower left corner to the upper right corner in the back. So it goes across all 3 dimensions. In this case, we do 2 triangles in a row, the pink triangle on the bottom of the box, and then the green triangle that kind of slices diagonally through the middle of the box. The second topic we need to know is how to graph a line. You're going to have an equation like this, y equals negative 2x plus 4. You need to identify that the slope is in front of the x and the y-intercept is after the x, or a constant. Once you know that information, you need to break the information into useful pieces. So slope is both the rise and the run. If you have a whole number like this, or an integer, you should put the number over 1 to create an equivalent fraction. Because my top number is negative, I'm going to say that the rise is going down, and the run on the bottom, since it's a positive 1, is to the right. Now, in order to use the slope, I need a starting point. So my first point is the y-intercept at 0, 4. This is the point where the line intersects the y-axis. So I counted up from the origin to 0, 4, plotted a point, and then from here I can use my slope to go down 2, over to the right 1, and I can keep following that pattern to find more points. Down 2, to the right 1, down 2, to the right 1, until I have enough points that I feel confident I can put a line between them and that it will look straight. This is useful for solving systems of equations. If both of my equations are in the form y equals, and they both have slope and y-intercept pretty easily identifiable, I can graph both of the lines to find the point of intersection. So here I have negative 3x plus 6. You'll notice it's a decreasing line. And then I have y equals 2/3 x minus 5. You'll notice it's an increasing line. And I see here at 3, negative 3, they intersect. This is the point that both lines have in common. That's why we call it the solution. The x and the y values are shared between both lines. Now, before we see other forms for solving systems of equations, we need to review a little bit about solving equations. Here is a general set of steps that will work for 8th grade equations. They won't work for every equation you will ever see, but you'll learn some additional techniques in 9th grade algebra. For 8th grade, we're going to start with distribution. For distribution, I'm looking for parentheses and a number on the outside of the parentheses. The number on the outside multiplies the two numbers on the inside, or whatever happens to be on the inside. My next line, I have negative 4x plus 8. Notice that this is a plus. I had a negative times a negative, which made a positive. You have to be careful with your negatives and positives when solving equations. Next, I'm looking for like terms. On the left side of the equation, I have an x term here and an x term here. On the right side of the equation, I have an x term and a constant, and those are not like terms, so I don't need to worry about combining like terms on that side. 5 minus 4 is 1, or negative 4 plus 5 is positive 1. There are more positives than there are negatives. Now my like terms are combined, I need to get variables to one side. In order to get variables to one side, when they are on opposite sides of the equation, we have to subtract or add. I like to start with a number that is smaller. So 1 is smaller than 10, so I'm going to take away 1 from both sides, 1x from both sides. You can do this either way, but you get fewer negative numbers to work with if you start with the smaller number. Next, I'm going to undo addition or subtraction. I'm looking on the side that has the x, and I notice we have subtracting 10. That's the first thing I'm going to undo. And then last, I have 9 times x. Even though there's not a time symbol, it means multiplication. So I'm going to do the opposite, which is division. In order to check my answer, I can copy the original equation, but instead of x, I'm going to put the number that we found it was equal to. If I work this out using order of operations, parentheses, exponents, multiplication, division, addition, subtraction, I see that on the left side we get 10 and on the right side we get 10. Because both sides are equal, our answer was correct. We can use solving equations to solve systems of equations as well. So a system of equations is just any set of equations that share the same variables. In 8th grade math, we only see systems with 2 equations. And the 2 types you're most likely to see are when we have y equals and another equation y equals, or we get y equals and then an equation in what's called standard form. And this will have some number in front of x minus or plus some number in front of y equals some total. To solve an equation, a system of equations that both start with y equals, we can set them equal to each other. If they both equal y, then they must equal each other, or at least they do at the point where they intersect. Here you can see an example where I've solved the equation. This is a good example to study if you're worried a lot about fractions. Here I had to add 3x, and before I wrote down my answer, I went off to the side and changed 3x to thirds. So 9 thirds is the same as 3 wholes. Put together, that's 11 thirds. And you'll notice these are the same equations that I showed in systems by graphing. So we get the same point, 3, -3 as our final answer. A common mistake when solving systems of equations is to forget to solve for the second variable. You need both an x and a y to show where the point of intersection is. If you're solving by substitution and one of the equations is in standard form, and the other equation is already solved for one of the variables, the easiest thing to do is to take what that letter is equal to and replace the letter in the other equation. So in this case, y is equal to 2x. So instead of y, I use parentheses and I replace the y with the 2x. I continue solving until I know what the x variable is equal to, and then I do substitution in the other direction, and I use the number to figure out what y is equal to. In the end, my answer is a point, x, y. Our last topic today is scientific notation. And there are, again, 4 different types of problems, and technically 6, that you might see under the header of scientific notation. The first thing we need to know is how to identify if something is or is not correct scientific notation. Here we have an example, 34.1 times 10 to the 8th. Now here we have 3 and 4 both in front of the decimal. This means that this is not correct scientific notation. You can only have one digit in front of the decimal. If I wanted to make this correct scientific notation, I would have to have 3.41. Make a note that the number in front of the decimal cannot be 0. Your number has to be between 1 and 9.99999. The second type of problem you might get is converting. You're either going to start with a number or something in scientific notation, and you'll be asked to move it to the opposite. So here, when I look at 39,100,000,000, I'm going to find the first digits until I get to the zeros. I copy those numbers down with the decimal in the appropriate place, and then I go back and count 3, 6, 9, and one more to get past the 9, but not past the 3. Notice where the decimal is supposed to land is between the 3 and the 9. Since we had to move 10 decimal places, the exponent is 10. Because this is a very large number, we have a positive exponent. If we have a very small number, then you would use a negative exponent. Same when we're working backwards. I start by copying down 2.1. And since this is a negative exponent, I'm moving 3 decimal places to the left, and this will create a very small number. Notice how scientific notation can either be a positive or a negative number. It doesn't affect our process, we just tack the negative sign on the front when we're finished. Multiplication and division requires us to know a little bit about our exponent rules. Here I have a division problem. 2.4 times 10 to the 6th divided by 1.2 times 10 to the 4th. The two coefficients in the front just get divided, per normal. But for 10 to the 6th divided by 10 to the 4th, we follow the exponent rule. When dividing two numbers that have the same base, we subtract the exponents. So our final answer has the coefficient answer times 10 to the 6 minus 4, which is 2. Addition and subtraction is the most complicated of these processes because we have to do some conversions. If we start with a problem where the exponents are not the same, we have to convert one of the numbers to be the same exponent before they can be added. This is like changing them to be the same magnitude. So here, I have 3.1 times 10 to the 2nd power plus 5.63 times 10 to the 4th. I like to start with the smaller exponent, and I think, how can I get this to be the same as the larger exponent? I need the 2 to increase by 2. Because I'm increasing the exponent by 2, I'm going to change the decimal place 2 spaces. They always work in opposite directions. So if I increase the exponent, I'm going to move the decimal to the left to make the coefficient 2 decimal places smaller. It's kind of like I multiplied by 10 and then by 10 again, but the other number I divided by 10 and divided by 10 again. Now that both numbers have the same exponent, we can add the coefficients, and when we're adding, we already determined the magnitude. The magnitude is the times 10 to the 4th. So we just take our addition problem and you just copy down the times 10 to the 4th. That's all for our pre-algebra review. That was a lot of 8th grade math all in one go. Feel free to go back, pause, and copy down some of these problems and try them on your own.